Assalamualaikum warahmatullahi wabarakatuh. We are from Group 7 and we are going to presentate about our project called Scoreboard on Previous 8. So, this is the scoreboard. Generally, scoreboard is a large board on which the score in a game or match is displayed. These are the hardware we use in our projects. First, button. Buttons is momentary or non-latching switch which cause a temporary change in the state of an electrical circuit only while the switch is physically actuated. An automatic mechanism returns the switch to its default positions immediately afterwards, restoring the initial circuit condition. And then we have battery. A battery is a device that produces electrons through electrochemical reactions and contains positive and negative terminals. A battery consists of one or more electrochemical cells, which transform stored chemical energy directly into electrical energy. When an external load connects to a battery, electrons cross from the negative to the positive terminal, creating an electrical current. This current may power motor, a light bulb, a clock, a computer, a cell phone, and other electronic device or equipment. Battery flow speed is determined by the battery's internal resistance and outside load. And then we have resistors. A resistor is an electrical component that limits or regulates the flow of electrical current in an electronic circuit. Resistors can be used to provide a specific voltage for an active device such as a transistor. And then we have 7 segments. The 7 segments displays are the oldest yet one of the efficient types of display used in embedded applications. This display has nothing more than 8 LED inside it. These 8 LEDs are separated into each segment, which can be named as A, B, C, D, E, F, G. As shown,
Assalamualaikum warahmatullahi wabarakatuh. My name is Damar T.N. and I'm going to continue Arka explanation of our hardware components. The last device is IC4026. IC stands for Integrated Circuit. Now, the IC4026 that we're using have total of 50 pins. 7 of them are for displaying the number by connecting it to the 7 segment display LED display. Now, the first pin is CLK or clock. This pin receives the signal or impulse and at every positive clock. So it will increase the number in the display, the LED display. The second pin is ENH or inhibit. This is connected to the power supply. And there is DEI, the third pin. It is a display enable input. And there is MR. These are used to reset the number on the display. There is CO or carry out. This pin produces 1 pulse at a counter of 10. So when the display reaches 9, then this pin will send signal that can increase the other 7-segment LED display to increase its number by 1. And there is DEO, the 4th pin, or disable enable output that enables the carry out pin. And there is UCS or the ungated C segment. This pin only used for dividing function. It is high by default and will set to low when the counter reaches 2. Then there is the ABCDEFG pin. These are the 7 decoded output from the A to G used to illuminate the corresponding 7 segment for displaying the number from 0 to 9. Next, this is our circuit. We choose the scoreboard circuit as our project because we think that the scoreboard circuit is pretty interesting and we want to recreate it on Proteus 8 as our project. As you can see, we've got 5 7-segment LED display with color of red, and we've got 1, 2, and 3 resistor, 1, 2, and 3 buttons, and 2 batteries. And there are also 4 IC4026 that each connected to their LED display. Now, this is the ampermeter and voltmeter analysis. From here, we can see that we've got the 12-volt battery and there's a voltmeter. This voltmeter are connected to the positive and the negative. And after we run it, the volt that we get is 11.9. Why is it 11.9 and not 12? And not just 12? Because we think that when we run it, the voltage will be run it through whole circuit and come back to the negative. That is what makes it 0.1 less more volt than it's supposed to be. Then there is the ampermeter. The ampermeter of our circuit is 0.59, or you can say 0.6. How do we get this number? By the Ohm laws, or which is V equal to I times R. V is the volt, which is the battery. R is the resistance from the resistor, which is on our case is R1 is 20 ohm, and I is current or ampere. Now, the formula to find the current is I equal to V divided by R. V is 12 and R is 20. So I, or current, is 0.6 ampere, which is correct according to this ampermeter or ammeter. Well, that is from me. Then my friend will continue the presentation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Allifya Rachman from Group 4, and I will continue what Damar explained before. Based on this picture, we have a 20 ohm resistor and 0.59 ampere. If you want to search the V or the volt, the formula is V equal I times R. Then we insert the number. The I is 0.59 or 0.6, times 20 the resistor. So the result is 12 volt. Next. Based on this picture, both ampere and volt is divided by other 6 segment. So if you want to search the resistor, the formula is R equal V divide I. The number is the volts is 1.5 divide 0.03 the ampere. The result is 50 ohm. Next, we run the circuit. Okay, this is our circuit, and here we have a 12 volts battery and 20 ohm resistor, and the ampermeter is 12 divide 20, so the ampere is 0.6. When I push the button, the voltmeter and the ampermeter is changed. The voltmeter is 11.9 volt and the ampermeter is 0.59 ampere. If I release the button, the scoreboard will change to 1. And also here is the quarter part. When I push this button, the voltmeter and the ampermeter is changed. The voltmeter is changed to 11.9 and the ampermeter is changed to 0.59. When I release, this quarter is changed to 1. And also here, when I push the button, the ampermeter is changed to 0.59. Okay, thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.